Greetings everyone, this is Non-Expert here, and today we are going to be talking about the factory method pattern, or the factory pattern for short. The factory pattern comes under the creational pattern classification, as it also deals with some sort of object creation mechanism. The intent behind a factory pattern is that it allows an interface or a class to create an object but lets the subclasses decide which class or object to instantiate. The reason why you might actually want to use a factory method is best illustrated by taking an example. So let's take a problem statement. So imagine that you're creating a transportation-based application like Uber or Lyft or whatever that you're comfortable with. So the business that you're building this application for only handles trucks. So the first version of your app can only handle transportation by trucks, so the bulk of your code lives inside the truck class. However, since you built out this app with only truck classes, you've basically tightly coupled your application. And what that does for us is it makes us less scalable to incorporate new changes whenever they come into the future. So if your app grows and you want to introduce new transportation mediums like ships, you would require a lot of changes in your code base. Apart from just changes in our code base, we might also end up breaking things which made our app successful in the first place. So the solution to solving this problem is by using the factory pattern. The factory pattern suggests that you replace direct object construction calls with calls to a special factory method, which would handle that for you. The objects are still created the same way, but the only thing that's changing is that instead of creating them yourself, you would call the factory method which would create them for you. Think of factory method as taking a bunch of inputs, adding a few conditionals, and then producing an output and returning back an object for you. Implementation-wise, implementing a factory pattern is pretty straightforward. You start by creating an interface or structure which all subclasses would follow. What this allows us to do is enforce specific structures on whichever subclasses that we have. The second step is whenever we create the subclass, we implement the same interface or structure. So all subclasses, or all sibling classes rather, will always have the same structure. They might have different behaviors, but the structure would always remain the same. The third step is we create a factory class, or a method would also do, which would generate objects of subclasses based on given conditionals and given information. And the last step is just to use the factory method whenever we create a class. Implementing a factory pattern is pretty straightforward, and you would always follow the same implementation no matter which language that you're using. However, there might be a few small differences, such as when I'm trying to code in Python, Python doesn't really give me an option of introducing interfaces. So instead of using interfaces, I'm going to use abstract classes to enforce those rules that we were talking about in the first step. The way to do that is by using a library called ABC, which stands for abstract base class. And I'm going to import an abstract method decorator as well, which will make all methods inside a class abstract as well, which basically means that it doesn't really have any body. So let's start by creating a class, an abstract class rather, called vehicle. And to make a class, an abstract class, you just inherit ABC in and you're good to go. For the sake of this demo, we're just going to make a simple function, which is going to be called delivery. And the purpose of this function is just going to be a simple print for now. To make this function abstract, I'm just going to make it abstract over here. Passing in the decorator would allow that for me. So whenever I try to instantiate this class, and let me try doing that right now, the expectation over here is that you won't be able to do so because abstract classes in the first place cannot be instantiated, and you also have an abstract method in which would enforce that rule. So you can see the error that we got. Now for the second step. Now, whenever we create a subclass or a vehicle like truck or ships, we would always inherit the vehicle abstract class. So if I'm creating a vehicle, let's say class like truck, I would always inherit vehicle in like this, which would enforce the rules which we talked about before. If a truck doesn't really follow that and does not really implement its own delivery method and override the abstract method that we have, it would always throw an error. So if we use something like foo and don't really do much with the delivery method, essentially whenever we try to instantiate the truck clause, we're going to get the same error because the abstract method needs to be overridden and we need to add some body into it. So over here, I'm just going to override it, and just for the sake of this demo, I'm just going to put in a print and just say in truck so that we know that's being called from truck. So now whenever I instantiate it, I will not get any errors as we basically followed the structure that was being talked about before. Now, if we want to create another class, like let's say ship, we can pretty easily, which basically would inherit the same abstract class that we talked about. And in the delivery method, I'm just going to change the behavior a little bit. Instead of just printing in truck, I'm going to print in ship instead. And we're basically good to go. Essentially what we've done is we've created two subclasses, which will always be, which will always have the same structure, but they would have different behaviors. Now, whenever somebody wants to create an instance of these classes, we would provide a factory method which would do that for them. So let's do that. Most programming paradigms actually allow you to create this pretty easily. And if you're coding this in Java, the way to override a particular method, you would actually write the override annotation. But in Python, you don't really need to do that. So I'm gonna come to step 3 where we just create a factory method, which is gonna basically create the object for us based on a set of conditionals. So it's going to take in an input, and I'm just going to call it vehicle type for now. And also I'm going to make a simple mapper, which is basically going to be a dictionary, which is going to take a key, which is going to map to the vehicle type, which is going to be passed in as the parameter, and then associate that with a particular class. So a truck would have a truck class and a ship would have a ship class. Now, all we're going to do is whenever this method is being called, we're going to use the mapper and we're going to pass in the vehicle type as the key. And if somebody passes in the wrong vehicle type, like let's say plane, it's going to throw an error as the mapper does not really have that key. And once this thing is returned, we're also going to instantiate that particular object which is being returned. Like truck will have truck object and ship would have a ship object. And we would basically return that in the factory method. And that's basically it. All we've done over here is basically create a factory method. And now whenever somebody tries to create an instance of a truck or a ship, they basically call the factory method instead. So if we have some function called as delivery summary, which basically gives you certain things like what was the summary of the delivery, which type of vehicle actually did the delivery, we can do that pretty easily by actually just calling the factory method and passing in the required inputs. So if we have a truck over here, we can just call it in and it will basically do everything for us. So if we want to do a quick sanity check, we can do that just by calling the delivery method. And the expectation over here is that whenever we call the delivery summary method, we would always get in truck over here as we're creating a truck object. And you can see that that's true as well. And that's basically it. You don't really need to make it too overly complicated. It's pretty straightforward. And even if you don't want to enforce the rules, like if you don't want to enforce the structure, the only problem that would create is that whenever you're having a subclass or whenever you're creating a subclass, you'll always have to make sure that it's sort of abiding to the same principles that the other subclasses are following. So it's a lot more easier if you just created an interface or an abstract class or some other method of just enforcing those rules in. And essentially, at the end of the day, all you need to do is you just need to make a factory method which would, based on a set of conditionals, create or instantiate your objects. Let's take a moment to talk about the advantages of actually using the factory pattern, apart from the obvious. So we avoided tight coupling, as you can see before, between the creator and the concrete products. Additionally, we also follow the single responsibility principle, as we can move the product creation code into one place in the program, making the code easier to support as well. So whenever there's a new class which sort of comes in, like if we have like a plane, that would be pretty straightforward as we won't really need to make too many changes in our existing code base like the delivery summary report. The last advantage over here is that we follow the open close principle, which means that you can introduce new types of products into the program without breaking the existing client code. As you can see over here, no matter how many subclasses that we provide, the code base never really changes as such. The logic or the business logic is still the same. And that's basically it. If you did like this video, do give a like and do subscribe to our channel. We are a discussion over here and we would love to have you on board with us. And if you did subscribe, you're awesome. We all know it, and have an awesome day. Thank you.